Math 3, Unit 4, Section B. We're doing the second page of this now. So on the back side here, we're talking about quotients. So quotients are when we're dealing with division, fractions, okay? So one thing is that in order to like reduce roots, if you have a fraction, they both have to be under the root. You can think of this problem as them each being under one root or two roots. Does that make sense? So this could have also been written as the square root with just a fraction underneath the root. Okay, those both mean the same things. With this problem or these problems, the easiest way is to try to simplify them first, because then you're dealing with less numbers. So looking at like the numbers, can 50 and 2 reduce? Yeah. And so I would cancel out the 2 and the 50 would become 25. What happens with the x's? So like I have x to the 6th on the top, x to the 4th on the bottom. Do you guys remember how those reduce? You subtract them is correct. And do you understand why you're subtracting them? If you're not sure, it's okay. So I'm just going to write this one out to hopefully make you guys understand it. So x to the 6th, do we agree that that means that there are 6 x's? Okay. And this is over x to the 4th, so that means there are 4 x's. And so, just like how on the bottom, how I had a 2 and a 50 and I could reduce, each x can reduce 1 for 1. Okay? So since I have 4 on the bottom, I can actually go 6 minus 4 and know that there's going to be 2 x's left over. Okay? So if you're ever not sure, you could just write it all the way out, but basically you're just subtracting. If the larger number had been on the bottom, then I would have kept the x squared on the bottom. So basically the exponent and the variable stay on the side with the biggest exponent. So right now, once this one has reduced, I'm left with the square root of 25x squared. So before we go any further on the problem, we want to look, is there an even exponent inside and is it an even root? Yes. Okay, because whenever they don't say it, it automatically is a 2, right? So a 2 is even and this is even. So since they're both even, I'm just going to put here absolute value may be needed. Okay, and then 25 breaks down to what? 5 and 5. And x squared, that's one group, right? Because for these, we just need 2 for a group. And so we write our answer as 5x. Do we think we are going to need an absolute value?
Yes.
Why? Good, it came out and it's an odd exponent, right? Not an even exponent. Now, does the 5 need an absolute value? No, because the 5 is already 5, right? It's only variables that may need the absolute values, okay? And so when it comes out, it needs it because it's an odd exponent. So we're just going to put an absolute value there around the x. Okay, do you guys feel like you are getting this? Kind of? Okay. Ask questions. If you're unsure about anything, I will stop and go back and re-explain it. Yes? Oh, I was just saying that, you know how these are both square roots? It could have also been like one big square root with the fraction underneath one square root, that they both mean the same thing. It's a 25. I reduced 2 and 50, yeah. Any other questions? Okay, so next problem on B. Can we reduce this? So 3 can go into 48 how many times? Okay, 16. And then this x can reduce, correct? And so this x is going to cancel out, so there won't be any x's on the bottom. And then how many will be on top? 2, right? So the 3 is going to change to a 2 because there was only 1 on the bottom. So it's like you're taking 1 away from the top. So you have left x squared. And then the y squared stays the same. So I'm going to rewrite this. And again, you could write it as 2 roots if you want to, or 1 root. It's up to you. So I have 16x squared, maybe I'll just keep it as 2, over the square root of y squared. So now you have to think of these almost like 2 different problems, but automatically right now, and actually I should have gone back to the when you first started the problem, okay? Even roots. Okay, these are even. Do you see the only exponent that has an even power is the y? Okay, and so I did this not at the correct spot here. You want to look at the beginning problem. So see how x here is cubed? We do not have to worry about absolute values with the x. We only have to worry about it in the original problem if they're both even. Okay, so the only one we have to worry about is the y. Okay, so now 16 is going to break down, and that becomes what? 4 and 4, so we have a pair of 4s, we have a pair of x's, and we have a pair of y's. Okay, so go ahead and try to write this answer yourself using absolute values if necessary. So on the top, we're going to have what? 4x. And on the bottom, we're going to have absolute value of y. Okay, so because y came out and it was an odd exponent, we need to put the absolute values around it. Okay, part C. Do you guys, this b is actually supposed to be just be a regular b to the 3rd. Okay, so what is the, starting in the original problem, what is the only thing that we have to worry about? Possibly the a squared, yes.
Sorry, but to go back to b, isn't
Yeah.
the exponent like the absolute value?
Doesn't the exponent what?
Doesn't the x and down an absolute value something?
No, because in the original problem, it was a cubed power.
Oh,
Okay. All right, so looking at the evens, the only one that may need it would be our A. Okay, so let's go through and reduce if we can. Can we reduce anything? So what can go into the 20 and 45? 5. So this becomes a 4, and this one becomes a 9. Okay, now what happens? You could do that, but let's go ahead and reduce the variables too. So since I have one A on top, this A will cancel out, and what happens to this A? It just becomes a 1, so I'm going to cancel this out. Okay, and then what happens with the B's? This one cancels out, and this becomes a B squared. So we'll rewrite this. So on top right now, I have the square root of 4. And in the denominator, I have the square root of 9ab to the 2nd. Okay, so when you break this one down, what happens? Okay, good. This becomes a pair of 2's. The 9 breaks down and it becomes a 3. What happens with the A? Good, it's left over, it stays inside. B squared, that's a group, right? Okay, so when I write this answer, let's go ahead and write it out. We have 2 over what? 3b root A. Now, there's a problem with this. And that is, I don't know if you guys talked about this last year in Math 2 or not, but you cannot have a square root in your denominator. Okay? And so we're going to have to skip down here for just a minute to talk about this. But it says another way to simplify a radical expression is to rationalize the denominator. So anytime you have a square root in the denominator, you will rationalize the denominator to get rid of the root. If you look at this example right here, so if you had 1 over root 2, in order to get rid of the root 2 on the bottom, how many 2's do you need to make a pair? 2. So if I multiplied by another root 2, that ends up making a pair of 2's to make this just a 2. And then on the top, whatever you do at the bottom, you have to do the top, right? Because that makes it equal. Because if I'm multiplying by 2 over 2, that's really like multiplying by 1, right? And 1 doesn't change anything, right? So it's just we're multiplying by 1, and it ends up just moving things around. So going back to this problem, what would I need to do? Exactly. And I want to show you something too, because I feel like it kind of gets confusing. But this is kind of like our answer. The only thing I was really worried about was the A, that may need an absolute value. At this point, because I don't need an absolute value, we are not going to need one in this problem, okay? And so now I'm going to rationalize the denominator, and the only way to get rid of this root A is by multiplying by another root A so that I get a pair of A's. But whatever I do to the bottom, I also have to do to the top. So this made 2 A's. Because remember how when you're multiplying roots, it's like they're both under one root? Yes? You guys remember that from yesterday's kind of lesson? So even though these aren't right now written under one root, when we multiply them, they really are. And so when I write this answer, it'll be 2 root A over, and then we write these in alphabetical order, so I'm going to end up writing my answer as 3AB. And at the end, once you get all these answers, you would reduce if you can, but in this case, nothing reduces. That's my answer. Because you can't reduce a non-root number with a root number, okay? All right, so we're going to practice more on rationalizing the denominator. Just like with multiplying, in order to reduce or do anything, they have to have the same index, okay? But for the most part, most problems will always have the same index. So on this first problem, is there anything that I could reduce first before I start this problem? No, right? There's X's and Y's, I can't reduce there. 5 and 7, those can't reduce. Also, can I break anything down to pull it out? Do we see anything? No, why not? Right, this one, if we notice, what is my index? 3. I need 3 of the same thing. So another thing is am I going to need any absolute values on this one? No. And so the reason is, and I'm just going to write it right here, no absolute values, odd index. Okay, so the only thing on this problem that we have to worry about is getting rid of the root in the denominator. Okay, and so I'm going to rewrite this just because I need a little bit of room to the side. How many 5's do I need in order to make a group on this one? I need a total of how many 5's? 3. How many 5's do I have right now? 1. So when I'm multiplying, I'm going to write the cubed root, and you can put 5 times 5, or you could write 5 squared, whatever you want to do. I'm going to write out 5 times 5 for now so I can see visually that I have 1, 2, 3, 5's now. Okay, so that's going to get rid of my 5's. In fact, we could go ahead and circle them if you want to. And then, oops, I wrote that wrong, sorry. How many y's do I need in order to make 3? I just need one more, right? So this one was y squared. From our problem, I wrote it wrong for a second there. So I just need one more y. Are we okay with that? Because I already have 2 y's here, so these 2 with this one will end up making 3 y's, which will make a group, because we need it to be 3 for a group. Okay, so my denominator now is going to be what? 5y, because I had a group of 5s and a group of y's. Is everybody good with that? Do we understand why I needed 2 5s and why I needed 1 y? My index here is 3. So in order to take out a group, you have to have 3 of the exact same thing. I only had 1 5, so in order to make a group of 3 5s, I needed 2 more. I had 2 y's here, so in order to make 3, I just need 1 more y. So you always have to look at your index to figure out what more do I need in order to make a group so that that root goes away from the denominator. Okay? Now, since I did this to the bottom, I also have to do it to the top. So I have to multiply both the top and the bottom by the same thing because that's like I'm multiplying by 1. Okay? So, could anything group to be taken out of the top? No. So all we do is multiply it all together. So I'm left with the cubed root of, and what's 5 times 5 is 25, and so then we have to go 25 times 7. Good, 175 is correct. And then I have an x and a y. And that's it, that's my answer. Ask questions. Any questions at all? No? Okay. So B. Is there anything we noticed that could reduce first? Okay, good. X is canceled. There's 1 and 1, we cancel them out. And then what happens with the y's? Good. These 2 are canceled and we're just left with a y in the denominator. So I'm going to rewrite this. So on the top, I have the square root of 3. And in the denominator, we have the square root of 5y. Okay. You guys try to finish simplifying this one. Let's see if you get it.
So when you make these a group, you're not multiplying them over here. Those just become 5. And then your group of ones just becomes a 1. Okay? And then on the top, there were no groups. So you have to keep those in the middle. Right. So the top is fine. So you have 3 times 15. I mean 3 times 5 y, so 15 y is correct on top. It's just that they're under the middle. Does that make sense?
Okay, so I didn't get around to everybody, but a lot of you got it correct. So the denominator, we can't have any roots in the denominator. So in order to get rid of this, we have to multiply by the square root. And this one is a square root, so we need 2 for a group. So I have 1 5, I need 1 more 5. I have 1 y, I need 1 more y. So this makes a group of 5s, and then we have a group of y's, 2 and 2. So my denominator is 5y. But whatever I do to the denominator here, I also have to do to the numerator. Are there any groups that I could take out of these roots? No. So we just multiply them together, and you have to keep the root. 5 times 3 is 15, so we have 15y. Can I reduce these y's? No. You can't reduce things. They have to either both be in roots or both not be in roots to reduce. Okay? So that's my answer. All right. C. Do we notice anything we can reduce? Okay, what about the numbers? What about 12 and 10?
2.
I can reduce by 2, right? So 10 becomes 5, 12 becomes 6. What happens with the A's? Okay, the one on top cancels. Good, the one on the bottom is A squared. So the B's, bottom cancels, and the top becomes B squared. And then the C's, the C on the bottom cancels, and that top one just becomes C. So we'll go ahead and rewrite this. We have the cubed root of 6b squared c on top, and on the bottom I have the cubed root of 5a squared. Do we all agree with that? Okay, so we need to rationalize the denominator. Okay, when we're rationalize the denominator, that's when we're getting rid of the root in the denominator. So what will I need to do? Good. How many 5s do I need? 2. So again, you can write that as 5 squared or 5 times 5. It's up to you. How many A's do I need? 1. And again, we know that we need these amount because of my index is 3. That means I need 3 of the same thing. Okay? So now I have my group of 5s, and I also have my group of A's. So my denominator will be what?
5.
Very good. The top, I have to, anything I do the bottom, I have to do the top. So I'm multiplying the top or the numerator also by 5 times 5 times A. Are there any groups on the top? Any groups of 3 that I can pull out? No, because we have a 6. That would break down to 3 and 2, but that wouldn't be helpful with 5. There's 2 B's, there's 1 C, and 1 A, so nothing has 3. So that means everything's going to stay under the root, and we multiply it all together. So 5 times 5 is 25, and 25 times 6? 150. And then you want to write your letters in alphabetical order. So I have an A, a B squared, and a C. And then again, why can't I reduce these? Very good. They either both have to be under a root or both outside of the root in order to reduce. Okay, so that's your final answer. Questions?